So, what are the odds? It's a question we ask about, well, everything. From whether it's going to rain tomorrow to our chances of winning the lottery. Today, we're going to pull back the curtain on the mathematics of maybe and give you a powerful toolkit for making sense of a pretty uncertain world.
You know, life is just full of uncertainty. Will it rain during the picnic? Will you roll that six you need to win the game? But what if that feeling of maybe wasn't just a feeling? What if you could actually measure it, give it a number, and really understand it? Well, that's exactly what probability lets us do.
We're going to break this down in 4 simple parts. First up, we'll see how to translate vague words like unlikely into solid, precise numbers. Then, we'll get to the golden rule, this one simple formula that's at the heart of everything. After that, we'll see what happens when perfect math meets the messy real world. And finally, we'll uncover how this hidden language is shaping your life every single day.
All right, let's dive right in with part 1, from words to numbers. This is that crucial first step where we take our gut feelings about chance and turn them into a clear, universal language that everyone can understand. We throw around words like unlikely or certain all the time, right? But what do they really mean? Well, math cuts right through all that fuzziness. Probability gives us this crystal clear scale from 0 to 1. 0 means it's impossible. It is never going to happen. 1 means it's certain. It absolutely will happen. And right there in the middle, 0.5, that's a perfect 50-50 shot.
And this simple scale, it's called the probability line, and it's our most basic, most powerful tool. I mean, think about it. Every single maybe in the entire universe, from the chance of a meteor hitting Earth to the odds of you finding a parking spot, can be placed somewhere on this line. It's how we can compare the likelihood of anything and everything.
Okay, this table here is basically our Rosetta Stone for chance. It directly translates our everyday feelings into their real mathematical meaning. So, unlikely, as you can see, covers everything from basically 0 all the way up to 0.5. Think winning the lottery. And even chance, like a coin landing on heads, that is precisely 0.5, or 50%.
So, we've got our scale. But how do we figure out exactly where an event belongs on that line? Well, that brings us to section 2, the golden rule. And it turns out it all comes down to one brilliantly simple formula. Now, before we get to the formula itself, we just need to get 3 key terms straight. First up is the experiment. And no, this isn't about lab coats and bubbling beakers. In probability, an experiment is just any repeatable action with a clear set of possible results. Things like rolling a die, flipping a coin, or drawing a card from a deck. Next, we have the sample space. And this one is absolutely critical. It's the complete list of every single possible thing that could happen. So for a standard 6-sided die, the sample space is just 1, 2, 3, 4, 5, and 6. Getting this part right is the foundation for everything else.
And our last term is the event. This is simply the specific thing or group of things that we actually care about measuring. It could be something simple like rolling a 5, or it could be a bit broader, like, say, rolling any even number. And here it is. This is the whole engine that drives probability. To find the probability of any event, you just take the number of ways it can happen and divide that by the total number of things that could have happened. That's it. That's the golden rule.
Let's put it to work. What's the probability of rolling an even number on a die? Okay, step 1. We know our sample space has 6 total outcomes. Step 2, our favorable outcomes, the even numbers, are 2, 4, and 6, so that's 3 of them. Step 3, we just plug it into the formula. 3 divided by 6 is 1/2, or 50%. See? Simple as that. So we have the theory down pretty solid. Now for section 3, theory meets reality. This is where things get really interesting, because we're going to explore the relationship between what the math predicts should happen and what actually happens out here in our messy, random world. And this brings us to a really key distinction. On one side, you've got theoretical probability. That's what the math says should happen in a perfect world, like a 50% chance of getting heads. But on the other side, you have experimental probability, what actually happens when you do it. You might flip a coin 10 times and get 7 heads. So why the disconnect?
Well, the answer lies in this really beautiful concept called the law of large numbers. It's the bridge that connects theory to reality. All it says is that as you repeat an experiment more and more and more, your actual real-world results will get closer and closer to what the theory predicted all along.
Let's just watch it in action. After only 10 coin flips, our result is way off, 70% heads. In the short term, randomness is king.
But as we bump up our trials to 100 flips, look what happens. It starts to correct itself, moving down to 55%. It's getting closer.
And after 1,000 flips, it's incredibly close to our theoretical 50%. Over time, all that randomness just smooths itself out, and reality starts to look a lot like the theory. It's predictability literally emerging from chaos. And this is not just some neat party trick. The law of large numbers is the foundation for entire industries. It's why a casino can guarantee that it will make a profit in the long run. It's how an insurance company can predict with amazing accuracy how many claims it will pay out next year. It's this profound idea that while individual events are random, the behavior of the whole crowd is incredibly predictable.
And this brings us to our final section, Your World by the Numbers. Let's use this powerful new toolkit to see how you can decode the probability that's hidden all around you. Ever buy a lottery ticket? Well, the odds of winning this particular jackpot are about 1 in almost 14 million. And that's not a guess. That number is a precise calculation using the exact principles of probability that we've just been talking about.
How about the 40% chance of rain on your weather app? That is pure probability in action. What it can mean is that historically, when we've had these exact atmospheric conditions, it rained 40% of the time. Or, like this chart shows, it could mean that meteorologists ran 30 different computer models, and in 12 of those simulations, rain was predicted for your area.
Honestly, once you start looking, you see it everywhere. It's in the drop rates for rare items in your favorite video game. It's a football coach deciding whether to go for it on 4th down. It's the algorithm in your email spam filter. And it's even the core logic helping a self-driving car navigate a totally chaotic street.
In the end, probability isn't a crystal ball. It can't tell you exactly what the future holds. But what it does, and what's so powerful, is it gives us the language to understand uncertainty. It provides a map for the landscape of what's possible. So I'll just leave you with this question. Now that you speak the language of chance, what part of your world can you see just a little more clearly?